Hello everyone, this is Daily Developing here. Today, this is the part 3 of the recursion series, and we're going to be solving two more problems two more recursive problems in this video. So let's start with this problem right here. So consider a game in which you have two powers, A and B, and there are three types of areas, X, Y, and Z, and you pretty much have to switch between every turn. And you have to find what's it called, a combination in which you can survive the longest period of time. So if you step in area X, what happens is A increases by 3 and B increases by 2. If you step in area Y, then A decreases by 5 and B decreases by 10. And if you step in area Z, now A decreases by 20 and B increases by 5. So you have to switch between every area. So you can't just keep every turn stay in area X and keep increasing A and B. You have to actually step in these other areas like Y and Z. And you just have to try to find a combination in which you can survive the longest. So in this case, let's say A equals 20 and B equals 8. So the longest possible combination will be 5. And the reason is this combination. So XZ, XY, X, this would be this will be the longest possible combination in which you can survive for 5 turns. You cannot survive on 6th turn. So on 6th turn, either A or B will be negative. Okay, so now we have to write a code that will let us pretty much code that will calculate the longest possible way, right? So in this case, right? So we can survive at max 5 units of time. This is where our code pretty much has to output. If we input 20 and 8, it has to give us 5 because 5 is the longest way. So now pause the video, try solving it yourself, and once you tried, then come back and continue watching this video. Alright, so now let's start solving it. The way I would like to solve it is I would like to create 3 functions. So first would be definition of max survival time in X, and we need A and B. Let's pass this function for right now. Now, all right, create Y and create Z. Okay, so we have these 3 areas. Let's quickly add a couple of things. So A increases by 3 and B increases by 2 in X. In Y, A decreases by 5 and B decreases by 10. Now in Z, A decreases by 20 but B increases by 5. All right, so these are our rules, right? And then we have to find the strongest combination. Now, I will print, so let's start with max survival time in X. I'm just going to start in X. I think, every single time when you try this combination, you would have to start with X, right? Because, I don't see a reason why not. We can start from anything. Let's just start with X. Just try to increase it. I don't see a reason why I should start from anything else. So make it X. Okay, now what we do is once we start in X, we have to do return. So 1. Okay, so we did survive this round. But then we have to do plus maximum between max survival time and Y. Now let's put this new A and B. Or max survival time in Z. Let's put this A and B. So what I'm trying to do here, by the way, for all of them who don't really know what min and max is, so let me try to show you. So in this case, right, there's 20 and 10. If you try minimum, let's say, is going to choose 10 because 10 is the least number, right, the lowest number here. Now if you choose max, then it's just going to return 20. Because it's just going to return whichever is highest. So this is the logic I'm using here. I'm trying to find in here, right, how many turns will you survive if you go in Y? And how many turns will you survive if you go in Z? And so now, all right, let's just say you will survive one turn more if you go to Z, then choose Z, right? Whichever is highest, that's the one you should choose. Okay, so that makes sense. Now, in here, so A minus 5, right? Okay, what we need to check here would be if A is less than 0 or B is less than 0, and then return false. I mean, return 0. So you did not survive this round, so it's not. I'm not gonna even return 1. And if A and B is not less than 0, then return 1 plus, because well 1 is like, yeah, you did survive this round, plus similar thing. But now you have to switch. So again, you can't really choose X here because next thing you have to switch, right? You have to do, I'm in X here, so now I have to switch. I have to go either in Y or Z. In here I'm in Y, so I can't stay in Y. I have to switch to X or Z. I can't just be in the same place. And for the max survival time in Z, let's just copy this. Or actually, let's just write it again. So if we know that A is less than 0, and we don't need to check B, because we know B is a positive integer here, and if we add 5 to the positive integer, then it's going to be positive. We know in this case that B is more than 0. B is not a negative number, so there's no reason to check. All right, and let's just return this. Now, you cannot be Z because you have to keep switching, so now you have to change it to Y. All right, so pretty much what we're doing here is all these numbers, right? So in X, A and B increase, by 3 and 2, decrease by 5 and 10, decrease by 20, increase by 5, and then just keep moving, right? We have to try, this is in recursion, right? Pretty much we're trying all the possible outcomes there, and whichever is highest should win. So let's see, let's run this. All right, so we returned 5. So and this is correct. So we can survive for 5 turns. All right. So this was our first problem. You can look at the code if you want. Now we're going to be moving to a second problem. So let's go to the second problem. So in this problem, we will be partitioning. So partition problem is to determine whether a given set can be partitioned into 2 subsets such that the sum of elements in both subsets is the same. So what does that even mean? So let's just say we have these 2 arrays. I mean 1 array, right? This 1 array of numbers. We need to write a function that will tell us whether or not it can be partitioned into 2 sets where the sum is equal. So in this case, right, 155 will be partition 1 and 11 will be partition 2, right? If you sum of this array is 11 and sum of this array is also 11, so it could be split into, I guess, 2 subsets where the sum equals, right? And then if we take this array, let's say 153, you can't really partition this, right? I mean, you can make something like, okay, 1, let's put 1 and 3 together, right? And then 5, but then those aren't really equal because this sum here is 4, sum here is 5. They're not really equal. So for that reason, you have to return false. So we have to write now a function that will let us know whether or not it's possible to partition it into or split it into 2 subsets where the sums are equal. So again, pause this video, try to solve it yourself, and only after you tried it, come back and start watching it. Look at the solution. Okay, so in this case, what we're going to be doing is, I would like to create 2 functions. So let's create can partition that will, in arguments, take array, partition 1, partition 2. I'll pass it for now. And definition just partition. Okay. So print partition. So let's just copy this array here for now. Okay. So now what I'm going to be doing is let's make this return can partition array and just blank arrays here, because let's start from this array. At first, partition 1 and 2 will be blank. All right, so now what I'm going to be doing, so you want to think about it in terms of recursion, right? So instead of solving for the whole thing at once, you have to use recursion. We just have to solve for the last number in this array. If we solve for the last number in this array and then throw it back into the recursion, then that would work. That would make things way simpler. So in this case, we know that the last number can either be, in partition 1, or it can be in partition 2. And by the way, no, we cannot just leave it be, we can't just skip it and not have it anywhere. No, we have to choose it. All right, so we really have to just try these two problems out. So let's just do it. Let's create a clone of partition 1. Or actually, sorry, let's make it last number equals to array, the length of array minus 1. All right, so let's take this last number. So now this last number can either be in partition 1 or 2, right? So let's create a clone partition 1 equals to partition 1 copy. Last number. Now, the reason why I'm trying to create I'm not adding the last number in partition 1. I'm adding it in the clone because it might not be in partition 1, right? We don't want to just add it to partition 1. We want to just see it. It could be in partition 1, or it could be a clone of partition 2. So let's just try partition 2 copy. Now clone partition 2 append last number. Okay, so it could be in first one or the second one. And now what we would do is return can partition the array. So in this case, we're going to take it from 0 to array length of array minus 1. So first of all, what is this 2 dot means? So if you put, for example, from 0 to length of array, that would return the entire array. That means from 0 to the end, the whole thing. Now, if we put minus 1, that means all except for the last one, right? So in this case, it will return an array with 1, 5, and 11, and it will not give the 5, right? So it's the whole array except for the last number. Now, clone of partition 1 and then partition 2. All right, or return can partition. Again, the same thing. So array, this thing right here, partition 1 or clone of partition 2. Okay, so let me briefly explain. Oh, and yeah, one check that we have to add here is if length of array equals 0, then we just have to return whether or not sum of partition 1 equals sum of partition 2, right? So for example, if this array is 0, so at this point we keep getting rid of the last number, right? Once we reach the 0, do sums equal? If they are, return true. If they aren't, return false. And so what are we doing in this last number? Okay, so in this case, we know the clone partition 1, right? So we added the last number here. So let's say in here, we added the last number in the first partition. Let's try this out. Will that work? Will that work, right? Will this return true? If this doesn't, then let's try to add the last number in the second partition, right? So we didn't add anything in partition 1 or 2. We added things in clone of partition 1 and clone of partition 2. So in this case, what we are doing is, let's just say it's not in partition 2. Let's just say we add in first partition. Will that work? All right. If not, will it work if we add it to second partition? And so in that way, it should iterate through all the possible outcomes and give us the answer whether it's true or false, right? So let's see if this works. All right, so we return true. Yep, that's great. Now let's try this one right here. So if this really works, we should optimize it. This should return false, right? Because you can't really partition it like this. All right, it returned false. But now let's add 1 here. So now it should still return true because 1, 3 plus 1 equals 5. And then, so if 5 is in partition 1 and all these 3 other numbers are in partition 2, that should work. So let's see if this, yep, return true. Now this could be partitioned into 2 parts. All right, now I just want to add like one, I guess, thing that would really make this code simpler, right? So we know what, if the sum of the array is odd, it can't be partitioned. So in this case, if this was like this, right? So 1 plus 5 is 6, plus 3, 9. There's no way, right? Because the whole point of splitting it in 2 means the sums will be the same, right? So the sum should be able to be split in 2. So if it can't, so if the sum, so let's just write it, if sum of the array is odd, then return false. All right. So by the way, if you don't know what this means, is this is modulo, right? So if it's divisible, if when you divide it by 2, it gives you 1 left over, right? So that means it's odd. Yeah, so all right. Yeah, if it's odd, return false. If it's not odd, then try to partition it. So I hope you enjoyed this video. If you did, please subscribe and put a thumbs up.